All right. So, for some of you, the graphical analysis for these problems makes complete sense and it works really well. Some of you, though, I know are just itching to have some equations to use. So, I wanted to introduce you to the kinematics equations. These are equations of motion. So, the word kinematics just means motion. All we're doing is solving motion problems. So, I just snipped the top left-hand corner of your equation sheet and put it here. So, this should look familiar. And if you want to get your equation sheet out to take a look, that's totally fine as well. I wanted to just kind of give you a tour of what we've got. So this very first equation, the one that you have up here, is the equation that we used in the first unit that we did together. And the thing that I want you to know about this, and you may want to write this down either on notes or you may want to actually just write this down on your equation sheet, is that this first equation can only be used if the acceleration is 0. So only use if the acceleration is 0. It does not work otherwise because it is assuming that your velocity is constant. Okay, so if your velocity is not constant, by that I mean it's changing, your velocity is increasing, decreasing, something like that, then you may not use that equation. Don't be tempted. Know that that is only okay if acceleration is equal to 0. The other equations that we have here, though, are the ones that you can use if you have acceleration. So now we're going to start looking just at the equations below that first one, okay? There's a little key over here to help you know what's what, just to keep everything in check and make sure that you're reading and understanding what I'm reading as well. So you've got your displacement, we've been talking about that, or position, you've got velocity, time, and acceleration. Don't worry about that gravity business. We'll get there very shortly, but we're not quite there yet. So I just want you to be aware of those and know what they are. And there are two other little things that are a little bit technical that I want to be clear on. One is that you'll notice that in these equations, it says delta t for time. The reason I typed it out that way is because that's how it's written in your book. But remember, delta just means change in. So you can think about that as the final time minus the initial time, as if you were looking at a watch. So the time that it started was at 12:15 and the time that it ended is 12:17. And so you could subtract those to get your delta t. Usually when we talk about time, we just talk about the amount or the duration of time. So as long as that makes sense to you, you don't have to write it out as a delta. I just put it in there that way because that's how it is in your book. The other thing to be clear that I wanted to clarify is that when you look at the velocities, generally there's a VI and a VF. VI is initial or the beginning velocity, and VF is final. So again, on the equations that are down below that blue line, we know that the velocity is changing. If it's changing, it makes sense that there's an initial and a final. So that's what those two mean as you're kind of getting to know these equations, okay? So everything that we did in the graphical stuff also fits with these equations. This is just the algebraic way to solve problems, okay? If you choose to do the algebra, just a friendly reminder that we're following the guess method. So you're always going to write down your givens, your unknowns, your equation, and by equation, just to be very clear, I mean one of these equations here, okay? Not with numbers in it, not any algebra. Like I want you to actually copy down the appropriate equation so that you know which one you're using. So you're going to choose an equation, then you're going to do some substitution, and then finally solve and include your units. Okay, so just very clear, that's what we're going for.